Good morning, everyone. And we were discussing about the fundamental cloud architectures. And in the previous classes, we had discussed about resource pool architecture and workload distribution architecture. Going forward, we will look into a kind of, a very special kind of architecture, what we call it as dynamic scalability architecture. Definitely, you people know scalability is one of the attribute, benefit, and whatnot. If you think about cloud, then automatically the scalability should be striking onto the mind, isn't it? So that's the relation between the scalability and the cloud, and that's how the scalability is being expected out of the cloud. So when you're designing an architecture for the cloud environment, definitely you have to take more care, and you have to come up with additional support for that scalability, isn't it, right? So at every point of time, when you talk about cloud and when you talk about its services, you will be thinking about the scalability. Well, that's good, but that scalability should be happening dynamically. That's what is the expectations level. Yes, of course, the scalability is being allowed, but dynamically it has to be increased and it has to be decreased. That means on a based upon the customer needs. Okay, whenever the consumption is more, automatically it has to scale upon it. In the sense, I mean to say, the cloud environment should be scaling upon the resource which is under consumption only. Like, if there are 4 resources and only 2 resources are being used, and there is no meaning in scaling all the 4 resources. But definitely there is every meaning in scaling of only the resources which is under more consumption, or else which is under the scale of the consumption levels. You got it, okay? So that's the importance of dynamic scalability, by the way. When it comes to the architecture definition, okay, you can come across that, nothing new we'll be discussing, but same type of scalings we'll be discussing. Okay, that is dynamic scaling has to be supported with horizontal scaling, vertical scaling, and one small new concept is being introduced here, that is dynamic relocation. Dynamic relocation. Okay, we will discuss one by one. Okay, so as it matters with the horizontal scaling, you people very well know that horizontal scaling is nothing but in and out. That means scaling the devices in and out. So this dynamic scaling should be capable of providing the resources additionally. That's what it means, isn't it? Right? So in horizontal scaling, you will be adding the devices and you will be removing the devices, isn't it, right? So more precisely, we can be telling that the resource will be, additional resource will be added or removed. So this addition and the removal should be happening in a dynamic sense. Dynamic sense. How this happens? There should obviously be a monitoring agent, what we call it as the listener. Okay, so this listener constantly looks into the resource consumptions and how the requests are coming in. Then accordingly, it will decide, okay, whether the resource has to be additionally included or not. Okay, that's about horizontal scaling in terms of dynamic scaling architecture. Going on to the next type, that is dynamic vertical scaling. You people know dynamic vertical scaling in the sense we'll be varying upon the capacity of the device within the availability of the device capacity. You got it, okay? So we'll be varying up and down. Either we'll be increasing the capacity within the device, or we'll be decreasing the capacity within the device. That means, again, there should be a proper mechanism for to estimate the load of requests that is coming in, so that the capacity of the devices can be scaled up or scaled down. Remember, this is purely the administrator's call, or else the architecture's call, to identify when to go with horizontal scaling and when to go with vertical scaling, provided the SLA should be arrived upon. That means if I have the SLA that is service level agreement with the cloud provider, that I can take up only the vertical scaling but not the horizontal scaling. Then my scaling will be only bounded with the vertical scaling. Though if devices are running, out of space, or else more utilization is being there, okay, then even then I will not be allowed to go with horizontal scaling if I'm agreed to it until or unless, isn't it, right? So that's how, according to the SLA, and depending upon the situation, the vertical scaling or horizontal scaling can be applied dynamically in this architecture. And the third one is relocation. Relocation. It means that moving from one location to another location, you are relocating yourselves. That's what it means. So when you are moving from one house to another house, okay, you tell that, okay, I am, moving, I am relocating from this house to another house. That's what. I'm relocating from one location to another location. Usually, you could come across this relocation term when you step into the software industry. Usually when you're looking for jobs changeover, okay, so probably you might be working in Bangalore, and you might be looking for the better opportunities, and if you get an opportunity somewhere in a good organization somewhere in Hyderabad, or Chennai, or Pune, or Mumbai, anything else, okay, other than Bangalore, okay, then you will be given something like a relocation benefits. You'll be given relocation benefits. That means you are moving, you are relocating yourself from Bangalore to some other location. You got it, okay? So similarly, in the dynamic scalability architecture, the relocation of resources can also be taken place. Resources can also be taken place. That means at first, okay, you will be equipped with certain resource, and based upon the consumption, you feel that this resource is not sufficient enough to withstand the request coming in. Then automatically you will have to change the resource entirely. Why? Because to an extent, you will be trying to scale within the device. That is, you can be doing vertical scaling, and to an extent you can be doing horizontal scaling also. But beyond that, these two scalings, okay, definitely you will be ending up with relocating the object itself. You'll be ending up with relocating the object itself. It is something like when you purchase a laptop, let us assume, okay, now laptop hard disk size is something like uh, what is that, 20 GB hard disk, and let us assume 2 GB RAM is being given. Okay. Now, over a period of time, you find that this laptop is not meeting your requirements, and you would like to enhance the laptop. So you will take that to the vendor, and you will see what can be, what measures can be taken. So probably if it has a capacity, yeah, what to say, if it has a capacity to take up the vertical scaling, in a sense, say few hidden sectors might be there in the hard disk, and you will retrieve that hidden sectors, and you will increase the capacity of the hard disk, say from 20 GB to another 2 GB might be increased. That, okay, you will be you consider that as an vertical scaling. Why? Because without changing the device, you are just increasing the capacity of the existing device only. Fine, that is about the vertical scaling. But later you come for the RAM. Okay, so you cannot scale upon the RAM. You cannot increase the capacity of the existing RAM. But what you can do is, as the another PCI slot for RAM is empty, you can go with additional device of RAM. That means additional 4 GB of RAM can be inserted into the PCI, and hence you can call that as an horizontal scaling of RAM can be done. Okay, fine. You do these things, and you will be working with that laptop for another 6 months or a year. But still, at later point of time, you feel that even that 4 GB RAM is not sufficient, and 22 GB of hard disk size is also not sufficient. Then what you will be doing? You will again walking into the vendor, and you will check other feasibility. Then he says, sir, beyond this, we cannot increase RAM as there are no PCI slots emptily available. That is it. And if I want to replace the device, okay, if I want to replace the device, then probably this device might not be sufficient enough to be compatible with the other components of the device. Okay, that could be one possibility. Or also when you talk about the hard disk, okay, you can claim that, okay, it cannot be further scalable. You have to include, or else you have to go for next level of scaling. That is, you have to go for horizontal scaling. Yes, for hard disk, yes, definitely you can be going with horizontal scaling. But what about the RAM? You cannot go with horizontal. You cannot further continue with the horizontal scaling, isn't it? So at that point of time, what you will be doing is either you will be changing the motherboard so that it can enable you to have additional slots of RAM, or you'll be changing the entire system. So that is what you'll be calling it as a relocation. Entirely moving your entities to other devices. Okay. So when you go for a new laptop, then automatically what you do, you will dump all your things into the new laptop and then you start working onto it, isn't it? So similarly, in the dynamic relocation, okay, usually dynamic relocations will be done based upon the SaaS and databases services. Okay, so usually you come across these in the dynamic relocation for those services. Okay, but not limited to that. Just memorize that. Okay, that's not limited to these services, but usually you find such kind of things there. Okay, so you will have to relocate your device. Now, the catch here is when to go with horizontal, when to go with vertical, and when to finally go with the relocation. How these things can be happening. Okay, let us look into a certain example. Okay. So on the slide, you can see two figures. First, let us go with the first one, the top one. Here, you could see that there are three clients. Okay, that is three consumers, cloud service consumers, and each of these cloud consumer is giving one such request to the cloud. One such request to the cloud. So this white bar, you can consider it as an the security measure or firewall. Okay, after going through the firewall, there will be one automated scaling listener. Listen carefully. This is automated scaling listener. That means this listener takes the decision when to go for scaling automatically, when to go for scaling automatically. So this listener constantly keeps on looking onto the requests coming in, and it will be directing these these requests to the resources in which the services are being catered. On the other hand, you can see that there is one virtual server, and on this virtual server, there are three service instances are being running, and these three requests that is coming in, okay, will be sending on to these cloud resources. I mean to say cloud services, isn't it right? So what happens is these cloud services will entertain those requests and give the response to the cloud consumers. This is the perfect scenario. This is well-fitted scenario. Now, what happens is if the cloud consumers are increasing, if cloud consumers are increasing, then automatically what does it mean? It means that the number of requests that is coming in is more, which means that the load on the resources are more. So what happens is the automated scaling listener, okay, it observes that there are few requests, okay, there are few requests that are waiting in a queue, and this waiting period is beyond the turnaround time. Beyond the turnaround time, it is taking more and more amount of time. Okay, it cannot sustain that waiting period to a longer extent. Okay, definitely it cannot go sustaining it to an limited period. It can allow the waiting to happen, but not beyond it. Okay, so considering these, okay, it observes that there are waiting requests, there are request waiting, and hence the services that are running are might not be sufficient enough. So now it has to take the call. It has to take the call. So what this automatic scaling listener does is, you can observe with the next diagram in the slide. Okay, so you observe that automated scaling listener identified that there are few here there are few requests missed out, or else they are in the waiting period. Well, let us not worry whether they are missed out or they are waiting for longer time or other thing. Okay, we can just tell that they are not being responded to in a quicker fashion. That means the response for these requests are not happening as per the expectation. That's what it means. Okay. So what this automatic scaling listener does is it initiates, okay, it initiates the resource replication mechanism. That means it ignites the tasks of a resource replication mechanism, and then what it does is this resource replication mechanism instigates the virtualization. Instigates a virtualization. That means it works on the virtualization of server hosts. That means previously there was only one server host catering three service cloud instances, sorry, cloud service instances, isn't it? Now, because of the information received from the automatic scaling listener, okay, this resource replication can go and increase the number of resources. Increase the number of resources. And this resource replication mechanism and the automated scaling listener will decide whether the kind of scaling that has to be adopted is vertical scaling or horizontal scaling or the relocation thing or the relocation thing. Okay, that's how it means. Okay, so this is how this architecture works. Now in the functional flow, let us interpret this architecture. So first three requests were coming in, and automatic listener didn't find any problem, and hence it entertained. Why? Because three requests are coming in and three instances are present, and hence one-to-one mapping is happening. So all the three requests are being entertained in a in meantime itself and in appreciated time itself. But when number of requests are coming in more, but these three instances, okay, are only existing, so the cloud listener try to observe how the requests will be entertained. So probably few requests can be entertained in a parallelly with the same three amount of instances. That means what little bit of vertical scaling of the resources is happening. That means previously 1-to-1 was happening. Now it might be happening 1 to 1.5 or 1 to 2 probably, isn't it, right? So let us assume 1 to 2 is happening. That means one service instance can be entertaining two requests. So over a period of time, or else depending upon the capacity of the server, it cannot go beyond that particular limit. Okay, so what the cloud listener does is it prompts the resource replication that we have to go for next level of scaling. So automatically it creates another virtual server with another three instances. So yes, this is happening. That means we have done with the horizontal scaling now. See, initially we had done virtual scaling. That is, we have increased the number of instances only. Okay, or else, we have increased the capacity of request response for each service. Previously, there was only one request and one service instance to entertain, but depending upon the scaling, we had one service instance entertaining two requests. So that means the capacity of the server instance is being increased. That's what we call it as vertical scaling. Now we see that okay, even these instances are not sufficient enough, and next level of scaling has to be done, and hence another virtual server is being created. So now this another virtual server will be coming up with same amount of server instances. Why? Because just a replication of existing server is happening, and hence the horizontal scaling is been happening, is being observed over here, isn't it, right? Now, even these virtual servers are not sufficient. What I mean to tell is, whenever you create the virtual servers, it will be coming up with another three instances. That is it. Okay. So, if you end up creating more number of virtual servers with the capacity of hosting only three service instances, then probably you might be ending up with more and more when the service requests are flooding in, isn't it? So at a point of time, the service instances, the servers which are launching the service instances has to be increased. That means one virtual server, as of now, it is able to come up with three instances of cloud service. Maybe you are supposed to develop or else come up with a virtual server that can cater around 10 service instances. So what you'll be doing is, instead of multiplying virtual servers, you will create one virtual server with entirely higher capacity. So what here exactly you are doing is, you are trying to relocate the service. You're trying to relocate the service. So this is how the dynamic scalability architecture functions. And definitely we would have come across you know like audit monitor, definitely resource replication monitor, and other things you definitely will be coming across. Okay, apart from the regular activities. Why? Because see, resource replication is not a separate mechanism. Resource replication is an embedded mechanism over here. You got it? Okay. And apart from these, okay, apart from the embedded mechanisms, uh, to enhance this architecture, you can come across other mechanisms like hypervisor. Why? Because we'll be creating additional hardware resources or else virtual resources. Okay. And definitely you'll be ending up with audit monitor, cloud usage monitor, and per pay per use monitor. Definitely, isn't it? Why we have to use this pay-per-use monitor? Because if you are using the scalability at vertical level, some sort of payment will be there. If you are using the scalability at horizontal level, another level of payment would be there. And if you are using the relocation mechanism of scalability, then altogether you will be ending up with additional payment, isn't it, right? So to have all of these in a proper sense, okay, these mechanisms will be coming us for rescue. That's about the dynamic scalability architecture. Now moving on to one more architecture, we will discuss another architecture here itself, which is similar to that of the prior one. And you call this fundamental architecture as elastic resource capacity. Elastic resource capacity. Now you might be ending up with one doubt, sir. What was the difference between dynamic scalability and elastic resource? Elastic resource. See, there is a difference between scalability and the elasticity. Scalability is driven by the application consumption, the service consumption. Elasticity is driven by resource capacity. It is something like vice versa. Like, you have to cater more number of services, and hence you are increasing. But elasticity of the resource is something like, at this point of time only, whether the services are being used or not, this much capacity of resource is being provided over there. You got it? But in the scalability, depending upon the service consumption, the resource is being allotted. There is a minute difference. Listen carefully. Depending upon the service need, the resources are to be scaled. That means the capacity of the resource has to be increased or decreased. But in elastic resource capacity, what happens is, whether the services are more or less, I don't mind. Whether the services are more or less, I don't mind. But I am supposed to provide this much resources, and hence I will be providing it. And accordingly, I am supposed to provide little bit of elasticity, then I'll be providing. That is it. You got it? Okay. In that sense, that means whether the demand from the service is there or not, the elasticity of the resources. Sorry. Sorry. I was telling that whether the in that scalability, in the scalability factor, what happens is, the scalability is driven by the resource demands or else the service demands, isn't it, right? Here in the elastic resource capacity, what is being driven? The resource capacity is being driven, and we don't mind whether the service is in demand, or it is either it is demanding the resources or it is not demanding the resources. I don't mind it. I don't mind it. That's how it is. Okay. It is something like, when you purchase a notebook, okay, uh, when you go and purchase a notebook, okay, you'll be thinking that, okay, I'll have to write 3 subjects in this notebook, and hence I'll be purchasing 300 pages notebook. So as and when you feel that, okay, these 300 pages are falling short, then immediately you'll be looking which subject is demanding more, and hence accordingly you'll be purchasing another book. And next time it is not necessary that you will be buying another 300 pages notebook. Might be you will be purchasing only 100 pages or 200 pages. So for example, in the three subjects, okay, you can by the end of the scenario, okay, you think that three subjects you have written on that notebook, on the 300 pages notebook, and you observe that one subject is done entirely and no need for you to write that subjects in future. And hence when you go for buying another notebook, you will be thinking about only to write the two subjects only, isn't it? So accordingly, you'll be purchasing the notebook. But here, if you don't think in that sense, and if you just blindly go and take another 300 notebook, thinking that okay, anyhow it will be coming for my use only. Okay, I'll be ending up with much more thing. So then you call that as an elastic resource capacity. That's the kind of minute difference between dynamic scalability and elastic resource capacity. In fact, this is one more reason why I have chosen both the architects to discuss in the same class. Okay, so in the elastic resource capacity architecture also, you will be coming across automatic scaling listener, okay, which will be constantly listening, and there will be a pool of resources that is available, okay, and there will be one intelligent automation engine, okay, this engine, okay, what we were talking about, okay. So what this engine does is automatically, when the automatic scaling listener identifies that number of requests that is coming in for entertainment is not able to sufficiently cater by the cloud service available, okay, it automatically triggers the intelligent automation engine. And this automation engine, okay, this automation engine accesses the resource pools and allocate the resources accordingly for the existing virtual device or for an existing resource. Remember, here we will not be creating new resources. We will be creating resource pools and we will be manipulating the usage of these resource pools. That's the major difference. In the dynamic scalability architecture, you can create cloud service instances, you could create virtual servers. For that matter, if it demands, you could create physical servers as well. You got it, okay. But in the elastic resource capacity architecture, no way that you will be creating a new resource, but definitely you can manipulate the resource. That means without creating the resource, okay, you will be ending up with, okay, additionally including the resources only, additionally including the resources to substantiate the load on existing resource. That is it, to substantiate the load of existing resources. It is something like you purchase the rough notebook, isn't it, the 300 pages notebook, and after finishing it, okay, you might be adding another pages or another notebook. That is it, another pages or another notebook, in terms of in order to substantiate the load that is being happening on this particular notebook. Why? Because the here the kind of load is you are ending up, you are you don't have space further to write, and hence you need some other entity. That's about the elastic resource capacity architecture. You got it? Or else I can tell you in much more simplest way. See, in the class itself, you are sitting and you found that your notebook is finished. That means your notebook is complete, and further to add your data, you don't have sufficient space to write it. So what exactly you'll be doing is you'll be borrowing a page or two from your friends, isn't it? That's how it is equivalent to that level, okay. Even that you cannot be calling it as a scalability. Maybe we don't say that these devices are driven by the scalability, though you find a certain amount of scalability here, but you exactly will not be calling it as a scalability. Why? Because the more essence is being elasticized over here in terms of elasticity of the resources. You got it, okay. So that's the eccentric of the resource being driven. You got it. Okay. So I hope I'm clear in explaining you the difference between dynamic scalability architecture and elastic resource capacity architecture, and how exactly these two will be differing, and why these two architectures are needed, and why these two architectures are categorized under fundamental architectures. Okay. So for these things to happen, definitely you will be needing again mechanisms like cloud usage monitor, pay-per-use monitor, and resource replication mechanisms. And no need for me to again explain what is the role of cloud usage monitor here, pay-per-use usage monitor, and resource replication monitor mechanism. It's same as that of the dynamic scalability architectures mechanisms. Only here also these things will be happening. But one classic difference what we'll be observing is when you come up with elastic resource capacity architecture, especially if you are going with allocation of multiple resources, maybe you might be ending up with rebooting of the system. You might be ending up with rebooting of the system. But remember, in the dynamic scalability architecture, never ever you will be rebooting. Never ever you will be rebooting. But here in the elastic resource capacity architecture, okay, you may be ending up with, okay, why? Because additionally the resources are being provided. It is something like, I had told you an example, like, in the virtual machine creation in the VMware, okay, first you create the virtual machine with 2 GB RAM. Now, when you are trying to increase the RAM, you have to bring that machine down. Okay, then increase the RAM or else increase the hard disk, and then you need to once again make it up and running. So that has to be happened. Why? Because the resources allocation should be properly handled. Should be properly handled. What happens if reboot is not done is, though you are allocating the resource, it might not be consumed in a proper sense. It is something like, you have the RAM, but still it is not available for the usage. You have the hard disk space, but still it is not available for your consumption. So in that sense, okay, definitely you have to do the partitions, and then you have to make it consumable, isn't it? If you know how the hard disk partitions are made and how these drives are being made, okay, logical drives, and how these things can be made, if you know that process, you can understand the empty space. Though I have 20 GB of hard disk, okay, if 5 GB of my hard disk is not partitioned, then it is not available for me, though it is present with me. Okay, so for these kind of proper utility or its proper usage of the allocated resources, okay, for this architecture, okay, demands the rebooting of the system entirely. Okay, so I will stop here for the day, and